Boa tarde. First, I just want to say thank you very much. I really appreciate the opportunity to come here to Python Brasil and to speak. I love Brazil, and this is any opportunity to come back is really nice for me. And so, with that said, we'll go ahead and get started. So, first, just a couple of words about me. So, I'm here from Austin, Texas, where we have a couple of things in common, I think, with Brazil, and one of them is our great love of barbecue. But also, Austin has a few things, I think, in common, in particular with São José dos Campos, which is that it's a tech center. And so there's a lot of sort of interesting and exciting work going on in and around tech in Austin, and there's also a lot of work in open source in particular. And, where I work at Continuum Analytics, we've tried very hard to be what I would call a modern open source company. That is a company that's built around a firm, strong commitment to open source technologies, to contributing back to open source technologies, to building communities around open source technologies, while also, of course, running a business and being able to sell things. And so, really, I just want to try to speak about some of those things today. When I'm not speaking about, that, I actually speak a lot about this project, Bokeh. This is what I do sort of my day-to-day. I'm the project lead for an open source project called Bokeh. It's a visualization library that lets you create interesting visualizations in Python, but show them in the browser, but also from other languages as well, languages like R and Scala and Julia. And it's grown into kind of a large project. So it's been an interesting experience for me to see a project that sort of started from nothing that now has users and has a community and has people supporting themselves. And so I think that's been a really enlightening experience for me, and so I'd like to share some of that experience with you, and that's really what I want to talk about today. Lastly, I guess I'll say, espero que algum dia eu podia dar palestra em português, but that's not today, but fortunately. But I do think it's important, I mentioned that actually not to subject you to my Portuguese, but because I think it's actually really fantastic to know lots of different languages, and that's not really just restricted to, human languages, but also to, thank you. I do tend to speak fast. Thank you for slowing me down. So I think that's also important for programming languages in particular. And especially for Python, I think this is one of the reasons it's been an exceptionally successful language, is that it plays well with others. It's really a polyglot language. It lets you sort of connect all kinds of technologies regardless of where they came from. And so I was just going to run through sort of my perspective on how things have evolved over the last, really 15 or more years, 20 years really, and to where they are today, just as sort of a precursor. So some of you might remember, Swig. So it's always been possible to write code in Python where you could call out to Fortran or C code, and it was very exciting. And sort of in the 90s, you could see scientists and people working with supercomputers leveraging C and Fortran libraries from Python, by using the C API. But that got kind of hard, and so someone came around and wrote Swig, which let you very easily wrap all these libraries with Python and call them from Python and use them at a very high level. That person was Dave. He's sitting back there. Somewhere back there. There he is. You can wave at Dave Beasley. So we're very thankful to him for sort of contributing all the amazing tools that he's given to us. And so Swig is a really fantastic tool, and people used it to great effect and did a lot of really great, simulations and computations and allowed people to drive things from a high level. And there's a lot of value in being able to drive your computation or your work from a very high level, but get, performance down from a low level. And so that's what Swig allowed people to do. So the next sort of stage was an evolution where we continued to use sort of C libraries, but maybe they were purpose-built. Things like NumArray and Numeric, people like Jim Huguenin and Piru created these, and then Travis came along and made NumPy and SciPy, and these also allowed us to write things at a very high level, but leverage other languages, sort of getting the best of all possible worlds, so to speak. A little bit later on, we had things like Cython, right? So Cython allowed us to wrap, again, languages like C and to leverage the possibility of these libraries in C, but do it at an even higher level, even more simply and more expressively, directly sort of from Python. And so that was extremely useful. Lots of projects in the Python data science stack use Cython. Things like pandas, pytables, and scikits. So all of these libraries, which have just seen an explosion of use in the last few years for data analytics and data science, all leverage Cython to some extent to do accelerations, again, to get that high-level expressivity, but then to get performance down, at a lower level. Beyond that, beyond C and Fortran type languages, we've also seen an explosion of people experimenting with the interpreter itself. Of course, we all know about PyPy, which is a tracing JIT compiler for Python that is written in Python, an implementation of Python in Python. But there's also things like IronPython and Jython that allow us to integrate Python very well with the .NET framework or with the Java world, because there is real value in those worlds. I mean, I love Python, but I can also recognize as a pragmatist that there's a lot of really good tools in the world and a lot of good value in those tools. And so the best position to be in is one where you can leverage all of those tools. Even more recently, there's been a push to have tools that can really take Python at a high level and drop down directly into low machine level CPU code, into GPU code. There's projects like Numba and Parakeet. This is by no means an exhaustive list. If you go search online, you can find all kinds of people working in this space where they're really trying to compile a subset of Python directly down into, again, CPU code, GPU code, which I think is pretty amazing. To be able to write a loop in Python and execute it on a GPU without having to write the GPU code is a pretty nice thing. And so it's just amazing all the wonderful work that people are doing in this realm. Of course, we all have the law that someday anything that can be run in the browser will be run in the browser, one day when browsers are our operating systems. So there's even integrations like Python, no relation to me, by the way, and PyScript, which allow compiling of Python to JavaScript. You're like, why would that be of interest at all? And actually, the Bokeh project that I mentioned, where we can create visualizations from Python, but display them in the browser, could very heavily use something like that, right? That's exactly the task that we've got, is to translate Python sort of at a high level into, low-level JavaScript, assembly JavaScript. So that's actually a very useful technique. And so it just goes to show that there's all this value in sort of making these connections and making, again, the opportunity to sort of use what's best in different places. And Python is in a especially centrally located place to allow us to tie all of those things together. Ultimately, that sort of has culminated lately with the IPython notebook, now the Jupyter notebook, and this is actually our code, Julia code, I think, running in the Jupyter notebook. I'm certainly familiar with the IPython notebook for many, many years, but it's pretty incredible what Bryan and Fernando and Min and the rest of their team have been able to do. I think there's something like 40 different languages that are supported as backends on the Jupyter notebook. And not only that, there's actually examples of people running multiple different kinds of code, Python alongside R, alongside Julia, in the same notebook in different cells. There's people working on being able to efficiently interchange data directly between these languages in the notebook. And so there's just an explosion of interesting and amazing work that all kinds of people are doing to sort of make the Python the centerpiece of a data analysis world. And a lot of that revolves around letting it, again, play nice with others, integrate well with other tools. And I think that's just a huge, amazing strength of Python. In general, though, I would say if you could pick a prediction from that, it's that, I would expect things to be very heterogeneous in the future. And right, come on, that's because they're heterogeneous right now. They already are. We have all of these multiple data languages and data storage formats. I was talking about just Python, but of course there's other kinds of things like, we have our NoSQL databases and our relational databases. We have all kinds of data stores. There's, data stored in dark web formats that people are trying to figure out how to index and how to search and make use of. And you talk about the Internet of Things, and so there's just going to be this explosion of devices as well. And so there's really just, there's no end to sort of the number of useful tools that are going to be around. And again, my personal take on this is that by working with them together, it allows us to play on multiple strings to get the best of all these different possible worlds. And again, Python is uniquely, I think, positioned to help facilitate that. And I think that is one of the reasons it's been incredibly successful. But this really leads into sort of my main thing that I wanted to talk about, really, that with so many tools available, there's actually a lot of opportunities to learn many different things. And I think that just learning by itself, starting to learn a tool, really is an opportunity to contribute. Really, it opens up the doors for you. People talk about contributing to open source projects. They often say, sort of somewhat cliched things like, PR is welcome. But there's a lot of other ways to contribute to a project, and that's really what I want to talk about, is sort of my experience with Bokeh sort of growing up and how that's sort of shaped my views. So just a couple of lessons that I've learned over the last, I guess it's been about 2.5 years now since we started the project. The first is learn from your mistakes, is that you have the opportunity to learn from your mistakes. So just to be clear, my good friend Katrina Reel, who's in this picture, she ended up getting a PhD in machine learning, and she's one of our head data scientists at Continuum. She was not making any mistakes in this picture. I was, however, making any number of mistakes. So, but hopefully since then, I've had the chance to sort of move on in my life and learn lots of things. And I think the same thing goes with open source software development. So there's definitely different philosophies regarding software development. There are a lot of folks who believe in agile development. makes things faster. Some people might say that it lets you make bugs faster. But on the flip side of that, you get to make fixes faster as well, because you have this connection and this interaction with your users at a very very sort of tight level. The opposite of that, I think, could be embodied by Dijkstra. So when I was an undergrad, I had the privilege of taking a class from Dijkstra at the University of Texas, and one of the first things he said on the first day of class was that, in his opinion, people would make less mistakes writing software if they had to chisel it in stone. And so that's sort of the opposite, polar opposite kind of view. And there's definitely examples of people trying that approach. I think my favorite example is in regards to the Shuttle Orbiter software group that developed the software for the space shuttle. I think in something like 3 or 4 decades of operation, 420,000 code, there were 17 mistakes, known mistakes, 17 errors, right? So that's it. I mean, I don't know. I've certainly made more than 17 mistakes in a day, I'm sure. But I can't imagine making 17 mistakes in 30 years. But there is a price to pay for that, right? It's still not zero. I guess that's an important point, is how do we learn from our mistakes, even if we put in that much effort from them? And the Orbiter group did just that. They had an entire meta process for examining how their process allowed the mistake in the first place anytime an error was discovered, because there were so few. But there's a price for that that's tangible in terms of economic terms. It's, I think, something like 1,000 lines of or $1,000 per line of source code in that software. So if you can't afford to spend $1,000 for every line of source code that you write, then I think it's imperative to figure out how you can leverage communities and open source communities and fast iteration with your users to help improve your software. And so that's really what I sort of wanted to get at. Kind of an example, counterexample to this. Here's another picture I took. I was on my way to debug some software one day at work, a previous job I was at. That's not joking. And I had to get on a boat. And so this was a sort of an extreme example of not being able to iterate quickly on software. This is an example where there was an extreme disconnect between the people writing the software and the users of that software. If there's a problem on the boat, where does that bug report go to? And there's certainly been examples of systems on boats, on submarines, on spaceships where there've been problems. And certainly it's an issue when you can't have sort of this iteration cycle very quickly allow you to make fixes. I guess the way I would put it, it's hard for all bugs to be shallow when the code literally goes to the bottom of the ocean. Again, I don't know where the bug report goes. Same thing with my phone. I love my phone, but it's not perfect. I certainly wouldn't say that it's perfect. And when there's an error with my phone, I have no idea where I can send feedback to or how I can get any kind of improvements made to the phone. There's just this sort of vast, corporate entity that maybe we'll get around to fixing the error someday. Maybe won't. Maybe they'll never notice it. It's just they don't have any of that sort of connection to their users, so they have to spend inordinate amounts of money sort of trying to test every configuration. So it's hard to iterate. It's hard to improve. My point is really just that if we want to learn from our mistakes, rapid iteration has definitely proved, to me anyway, to be a very sort of important, very important concept. And it's really about having that connection. Again, this is one of the freedoms that people talk about in open source is obviously, free as in beer, your cost of ownership, or free as in freedom. But there's other freedom which I think is important, and that's just the freedom to connect, right? The freedom for people to make contributions, to give you feedback, to have this sort of connection, this loop. And that's, I think, maybe overlooked, but a very important sort of freedom of open source software. But it's not just about the pull request. I mentioned that it's people say, oh, pull requests welcome, and that's a very high bar for people to jump in. I think there's actually a lot of ways for people to get involved in open source software and to contribute to it that don't involve necessarily code. I think communities are built from more than code, and I'll talk more about that as well. So just to go over that, I guess this is sort of the superficial view of open software that I had encountered in the past is that okay, the software is open, so someone creates it, and it just exists. And then people can take it and use it. So in particular, companies can take it and use it, or individuals, or academics, or users can just come and take it and use it, right? Sort of free as in beer. That's sort of one view of open. Another sort of view, more maybe the true economic view of open, is really that there are contributions coming in, that people make valuable contributions to your project. They add code or documentation or tests, and all of this is very valuable activity and serves to make the project more valuable. I think a more innovative way to put this, and by the way, I'm borrowing these slides from Luis Ibanez from Kitware, but another way to, wrong direction, there we go. Another way to think about it is that really the openness here is about ideas, is about information, is about connecting people together. That, I think, is the valuable sort of openness that has mattered a lot to me, because once you start having open source software and you start having people use your software, you really want to try to foster a community around that so that it can self-support itself. And that's not easy to do. That takes some effort. But that's, I think, the most valuable view of openness because it allows the wisdom of the crowd to come and help you make the software better. Again, it's all about playing to different strengths. Just as with different languages, getting different people involved is also very valuable, and different ideas. Another lesson is that open source software doesn't just happen, right? So this is another reason why I think that last view is very valuable because it doesn't just exist, right? The first view where there's just software that exists and people can take it and use it is great if there's some, magic genie that can sort of bestow on us amazing, great software all the time. But that's not true. It's actually a lot of hard work by a lot of people doing all kinds of different work, doing work to help making sure your automation and your builds work, working to make sure that your testing is going on smooth, helping with your releases, helping with documentation, doing your user testing, getting feedback and issue reports from users or feature requests. One thing I will mention that we love to get, we don't always get enough of, is if you do something cool, please let us know. That's one of the most important things. Is I'd love to get sort of good feedback, and this is working. And sometimes when things just work, that people just use them, and that's great. But certainly open source devs love to hear about success stories as well. But all of that work is important to contribute in the community. And again, once you have enough people using and working and talking about the software, then sometimes they begin to self-support, and we'll talk about that again in a bit as well. So here's a quote from my boss, Peter. He's one of the co-founders at Continuum. Is open source is too important to be left as just a hobby for smart people to tackle in their spare time. And I think that this is true as well. I think this is one of the reasons I'm really grateful to have the opportunity to be at Continuum and again, to have what I would call a sort of a modern open source company where we try to make direct contributions and we try to focus efforts on specific goals to make open source better. I think that there's a lot of tangible benefits from that. We'll talk about it in a bit. Because, a lot of people do amazing things in their spare time, and I hope that I've done a few things, and I hope everyone in this room can do really cool things, but it's good to have sort of focus and to have collaborations between academics, between business, between nonprofit organizations that are helping foster the environment, and between individual users. And so all of that takes, again, effort. It doesn't just happen out of nowhere. Or necessarily as a distraction from PhD research. There's another slide I stole. This was Jake Vanderplas. He's the author of one of the scikits, and he's done just amazing work in developing great data science tools for PhD or for Python. But he was complaining, I think last year, that stop taking all of our good astronomers. So he's an astronomer. But of course, he promptly went out and published his own book on data science. So I don't know. We can take that with a grain of salt, I guess. But okay. What other interesting lessons maybe we learned? So the first is that users are sort of always watching over and sort of paying attention. It's easy to get sort of in a place where you're working and you don't think about necessarily what's going on outside you, but there's always people trying out and using your software and especially if they're trying to use it in an important project, then the decisions you make are important to them. And so it's always good to be cognizant of that and to remember that. Again, there's a lot of benefits that come from this as well. All bugs are shallow, as the saying goes. But if you dig down into that a little bit more, I think the main thing to note is that, some places where open source software really thrive are areas where you need great and rapid innovation, or also areas where you really want great stability. And it's kind of funny that these are actually sort of the extreme cases, but they sort of they work for the same reason, and that's that community helps both of them, right? In the case of innovation, it's really the wisdom of crowds. It's getting all this influx of ideas from many, many people, sort of melting them together and combining them and mashing them up and figuring out what works. And that helps you iterate and innovate and make really rapid advancements to your software, to your open source project. But there's also the community of maintainers. If you want to have long-term health for your project, if you want your project to exist in 15 years, it absolutely depends on having a community around it, people who will come on board and want to help shoulder some of the burden for fending off bit rot, fending off the maintenance problems that occur, making sure it still exists. I mean, NumPy is such a successful project because there are a lot of people who've come in and have sort of taken over and taken the torch up of keeping it working and keeping it moving forward. And again, that requires fostering and developing a community, right? They sort of amortize the cost of bug finding and maintaining your project over time, or maintaining the project over time after it's no longer just yours, right? Because certainly at some point, if you develop a project that's popular enough, you have to come to grips with the notion of sort of ceding control. And again, one of the one of the things that's been gratifying for me is that this is finally starting to happen a little bit with Bokeh. We sort of see other users answering other users' questions, and I think that's sort of a critical mass. I think this is really important for the life of a project, and you can sort of see this a lot on projects on Stack Overflow or on mailing lists where users are answering each other's questions. This is something to encourage and something to foster. You have to sometimes take a step back and not try to answer everyone's question. Let other people try to have an opportunity to do that as well. So that's, I don't know, I think that's a really important thing. Another sort of thing that I maybe have noticed, and this is maybe just a silly truth, but it's that, the reason we can get where we've got is because there's already so many great tools that have come before us, right? I could imagine trying to climb up to Pound Yasuka by foot, and it would be really hard, but I don't have to do that because I can take a nice cable car up to the top because someone has built that before, and now I can sort of I can benefit from that existing. And the exact same truth is true in open source software. Bokeh is built on a lot of complicated pieces of software, things like Tornado, and lots of JavaScript libraries, the existence of JavaScript in the browser at all, really. All kinds of libraries that we use, and that's the reason we're able to sort of build so much. And my best hope is that someone will come along and take Bokeh and build up something even better with it, something at a higher level or more sophisticated, or something that's really exciting for research or for commercial endeavor, whatever. Just that's my hope, is that someone will use this, and it's this network of usage between products and projects that really forms a community. So we'll see where that goes someday. And last, I think, slide I hear, lessons, is just to sort of talk about how I feel in terms of open source in connection with business. What I've learned in the last few years is certainly that open source can be really good for business. And there's certainly a very superficial way in which this is true. Obviously, open source software is free as in beer, and that's fantastic and that's great, and that possibly can lower the total cost of ownership of software. But it also makes sense to give back and to contribute, and to sort of, it makes business sense to actually, excuse me, to be a leader in open source software. And there's a couple of ways that I've seen this be beneficial to companies. One is that when you are very active in open source communities and in building open source communities, you establish for yourself technical leadership, and this can increase demand and credibility in the market for your services. So if you're doing consulting, certainly one of the best testimonials you can have is to be one of the active contributors, core contributors of whatever projects are in and around the kind of work that you're doing. And so that's absolutely a driver for business, and I think it's very important to sort of gain that credibility and to help spur demand by making these open source contributions. I've seen that happen, and so I think there's a clear case for that. It also can form the foundation, both in a technical sense and in a trust sense, for paid products. If you're developing, paid products for enterprise or for your clients, which is a perfectly reasonable thing to do. We're in a business of running a business, we have to sell something in this kind of economy, and that's okay. But working on these kind of tools and making these kind of contributions gives people something that they're already familiar with, right? If you've done the effort and the work to build a community around a set of open source tools or made your contributions to it, that says something. And again, that can establish trust. And then if you want to, or if you build products on top of these things, people, they aren't just coming out of nowhere. People sort of know what to expect, where they came from, who they came from. And I think that that's also really important as well. So really, it's all about I would say aligning incentives, right? It's about making sure that obviously there's a cost associated with doing open source and making those contributions. You can't just do it for free. You have to eventually make some money somewhere if you're running a business, and so it's about aligning incentives. It's how can we make those contributions that give something amazing and wonderful to the community. And help build the community while also letting you build products or services on top of them that let you delight your customers, that let you keep the lights on at the end of the day. And so again, for me, this has sort of been the lessons that I learned, things that I didn't know coming into this a few years ago, is how important these could be. And so I'm glad to have seen that happen both for Continuum but also for other people I know in other companies where they're starting to make contributions and making very important contributions to open source software. Okay. So that's sort of some lessons, like I said, lessons I've learned, and a lot of them are probably maybe fairly obvious, but I don't want to restate the obvious. But I put them together in one place because they're sort of meaningful to me from my experience. Like I said, it's been a very transformative one for me, going from 0 users to having some users and now kind of a lot of users. It's very humbling and certainly gratifying, but it's nice learning some things along the way too. So I would say, what is it possible that everyone else can do? Well, obviously, there's sort of the standard stuff. You can be very vocal. Bug reports are very appreciated. Feature requests, let people know what do you need. Again, it's this interplay of ideas. That's the sort of the innovation value of open source, is that it allows ideas to come from everyone in this room, everyone outside this room. We can really sort of get the best of all possible ideas together and try to use those, refine them down to the best ideas, and use those to improve our open source projects. Of course, people say the other, again, sort of a cliche, PR is welcome. If you have the ability to, certainly getting directly involved in development with code and tests and docs are an amazing way to contribute to an open source project. But that's not the only way. So that's why I say it's, in scare quotes, PR welcome, because that's not the only way to contribute in open source by any stretch. Honestly, like I said before, we really, really want to hear, if you do something cool with an open source project, devs love to hear about that. I try to snatch little bits and pieces from the ether from Twitter. People said, hey, I've done this cool thing with Bokeh, and I'm like, I want to hear about it. I'd love to talk about it or see what you did, show it off or retweet it at least. So if you do something cool, if everything just works, that's also good news and good things to hear as well. So please let people know. It's always good. But just in general, I encourage everyone to try to learn as many new libraries and tools as possible, right? Try to see how their different strengths can be combined. Try to see how can we take the best bits of R or Scala or Julia and combine them with the best pieces of Python, put them together, mix them up, mash them up in different ways. I think that's really valuable to have that sort of mix-up culture and mash-up culture, I guess, where you put everything together and you see what's the best of all the different things that we have. And then finally, you can also invest in open source as a company. If you have the ability to do that, it's a great thing to do. I'll talk in a minute about some places that are great at sponsoring, and helping and pushing forward the community. But directly helping out open source is always something I think that's good. Again, good for business is the last slide that I've mentioned. And then finally, just share your ideas and knowledge. This is that whole idea about the ideas are the valuable currency. Sort of getting everyone together and talking about their ideas, talking about their knowledge, self-supporting, having users who can help other users. And again, this is sort of the foundational things that build up a community of people, which again, to me anyway, is really one of the most paramount things. So I think I'm actually getting close to being done a little bit too early, so I apologize for that. But a few more slides. I did want to point out, just to call out a couple of different things. One is APR, right? IPR, I think. And so this is there's two organizations I wanted to call out just that help foster the Python community. So this is one that helps foster the Python community and protect the Python trademark in Brazil, helping find and send speakers. So if you want to support open source initiatives, you can reach out to organizations like this and offer them material help, and they can in turn offer help to projects. Another one that's near and dear to me is the NumFocus nonprofit foundation, another nonprofit foundation. They promote and support ongoing research, development of open source projects, especially around data science and the PyData stack. They currently sponsoring 12 projects, 1,900 contributors, and 3 million lines of code are sort of under their sponsorship. And they have sponsors like Microsoft and other companies that come in that help. And so they help offset administrative or travel costs for open source projects so that they can send people to conferences like this one to interact with other people, with other users. And I think that's a really valuable thing. So just wanted to make sure to call out those. Excuse me. Just wanted to make sure to sort of call out a couple of those organizations that I think do tremendous work towards helping keep the Python, sort of greater Python community active and alive and moving forward and helping to support open source projects as well. I guess the last thing I would leave you with is just a simple sort of slide here. The main point, if I could leave you with one idea, is that really the community is greater than source code. And the reason for that, I hope, is fairly transparent. That's because source code doesn't take care of itself, right? If I just write some code and I throw it into the wind, and is it going to work in a year? Who knows? But if I develop a project, or if you develop a project and you help build a community around that of people who can support and maintain and nurture that project, it has a lot better chance of existing in 15 years and it's still being around and relevant. And so I think that's just it's definitely a truism that community is greater than source code. And that's something that I maybe didn't appreciate a few years ago that I appreciate now. And so that's really what I wanted to share with everyone here today. And that's really all I have. So I guess if there's any questions, I would love to sort of take questions and have a discussion. Okay.